Testing one. All right. Hello everyone. My name is Glen Owen, and today I'm gonna show you guys another lecture. But before I explain about physics lecture, so now on I'm gonna explain about my chemistry lecture. The subject that I'll be explaining it's pretty simple, which is chemical calculation. So let me share my screen for a while. And all right, in here we have my first slide, which is of course the title is chemical calculation, which created by myself in the PowerPoint. And yeah, in this lecture I'll conclude some general information and units of each how to say it, units of each formula, and also some sample questions. So yeah, let's go to the next slide. Okay, first of all, this general information is, to be honest, is what you'll need on this chemical calculation. So first one, we need our periodic table. So some of you maybe don't know what is periodic table, so here I'm gonna explain it. Periodic table is a tabular display of the chemical elements which are arranged by atomic number, electron configuration, and recurring chemical properties. So yeah, this periodic table is the one that displays on the first slide. And this is the periodic table, and this one is atoms, like the free elements in each periodic table. Like for example, this could be the hydrogen or maybe other elements. Yeah, after periodic table we'll have molar mass. So molar mass, or some people call it relative mass, is the sum of the masses of the atom that make up the formula or molecule. So in conclusion, molar mass is like the total masses in a one compound. So example, you have the hydrogen monoxide, which is H2O, which means you just add the mass of hydrogen and oxygen, and H2, which means 2 hydrogen, so you need to multiply the mass into 2. So 2 plus the molar mass of oxygen, which is 16, and the molar mass of the hydrogen monoxide will be 18. So yeah. Also, the units of molar mass is gram per mole. Why we don't use kilogram is because atoms and other sorts of compound are really small, so we'll just use gram so that it's simpler. To the next one, we have mole. Mole is the amount of substance that has the same number of particles such as molecules, formula, unit, and atoms. So mole is the one that's in here. This is mole. And next one, we also need Avogadro's number or Avogadro's constant. So Avogadro's number is the number of molecules, atoms, compounds, etc. per mole of a substance. And the Avogadro's number is equal to 6.0222 times 10 raised to 23 per mole, or simply 1 mole is equals to 6.022 times 10 raised to 23 particles. So in this one, there's called particles. What can I say is that Avogadro's number or constant, there's also some units. So I'm gonna explain this in the next slide. Units of particles. So just like I said, there's 3 types of units of particle, which is the first one will be formula unit. So The formula unit, this unit is used when the substance is an ionic compound. Maybe some of you don't know what is ionic compound, so I prepared this. Ionic compound is a neutral compound made out of positively charged ions, which we call cations, and negatively charged ions called anions. So in here I have the example of ionic compound. We have potassium chloride, which contains potassium ions and also chlorine ions. Okay, let's continue. We also have molecule as the units of particles. So molecule, this unit is used when the substance is a covalent compound. So what is a covalent compound? Well, I prepared this now, just in case some of you don't know. Covalent compound is a non-metals that form a chemical bonds with each other. Example like, yes, water, dihydrogen, or maybe scientific name, dihydrogen monoxide. We have H2O, which both of these are non-metals. Let's continue to the other units, which is atom. This unit is used when the substance is a free element. Well, for me, maybe some of you don't know, so I already prepared this. Free element is any element that is in an uncombined state, which is like they're still alone. Example like iron, like iron ion. Right, since I already explained to you guys the units of particles and general information in chemical calculation, we will proceed to the sample questions. There will be 2 sample questions, and here we are. Here are the sample questions. So let us discuss this together. Now we'll answer the first one. Number 1, how many particles are there in 70 grams of calcium nitrate? So in here we are given the mass of calcium nitrate, which is 70 grams. And what we need to do first, the first thing we do is that we need to find the molar mass of calcium nitrate, which is in here. These are the solution that we explained for a while. Molar mass of calcium nitrate is equals to the mass of the molar mass of calcium plus the molar mass of nitrogen times 2, since in this one the nitrogen is inside a bracket of these 2, and plus oxygen time, and plus molar mass of oxygen times 6, because in this one inside the bracket there's 3 oxygen, and you multiply by 2, which will become 6, and it's equals to molar mass of calcium. There it will be 40 plus molar mass of nitrogen, which is 14 times 2, since there is 2 nitrogens, plus 16 times 6, because there's 6 oxygen atom. We'll calculate this all, type it on your calculator, and the result will be 164 gram per mole, which is the units of molar mass. Now, maybe some of you think like, now what we will do again? We already found our molar mass. What do we do again? How do we find how many particles are there in this calcium nitrate? Well, in here we just convert some things. Right, here you are. So first of all, convert things is pretty simple. First, you put your given mass 70 grams, then you need to cancel this gram. So we use this 1 mole per 164 grams, which we just obtain this from the molar mass, which means 1 mole is equals to 164. So we can cancel this gram, cancel it. And after that we need to cancel this mole. So by that we multiply this by the Avogadro's number, which is 6.022 times 10 raised to 23 formula units. Yes, we use formula unit because calcium nitrate is one of the ionic compound, divided by 1 mole, because Avogadro's number is equal. 1 mole is equals to 6.022 times 10 raised to 23. So yeah, after that you can cancel this mole, and then you type all of this number into your calculator. So grab your calculator, 70.0 times 1 per 164, multiply again, 6.022 multiply by 10 raised to 23 divided by 1 mole, divided by 1, and your result should be 2.57 times 10 raised to 23. Although in your calculator there will be a very long answer, I just use 3 units since in here I put 70.0, which means we follow the significant rules. So we follow the least number of significant rules for the final answer. So the final result will be 2.57 times 10 raised to 23 formula unit. Now let us continue to the second question. Now in here we have how many particles are there in 18.6 pounds of glucose. So given that the mass of the glucose is 18.6 pounds. So likewise, we need to find the molar mass of glucose. So molar mass of glucose is equals to 6 carbon plus 12 hydrogen plus 6 oxygen, all of their masses, and we'll add it, 12 times 6 plus 1 times 12 plus 16 times 6, and you'll just count it all in here in your calculator, and it will be 180 gram per mole. And yes, just like before, we use the conversion. We have 18.6 pounds, so we need to convert these pounds to kilogram first, which is 1 kilogram is equals to 2.2 pounds. So yeah, we need to cancel these pounds, so we put the pounds below and the kilograms and above of it. So 18.6 pounds times 1 kilogram divided by 2.2 pounds, then you close the parenthesis, then times, we need also to cancel this kilogram, since in chemical calculation we use gram. So we need to cancel the kilogram by multiplying 1,000 of gram divided by 1 kilogram, since 1 kilogram is equals to 1,000 gram. In here we can cancel our kilograms, and then we need to cancel the gram, we need to cancel the gram with our molar mass, which we obtained it before, which is 180 gram is equals to 1 mole. So we put the gram below and the mole in the above. So this one is multiply 1 mole per 180 grams. And then you need to cancel this mole. By that, we use our Avogadro's number again, 6.022 times 10 raised to 23 molecules. Now, why I use molecules in here is because it's a covalent compound. It's all non-metals that forms a chemical bonds: carbon, hydrogen, and oxygen. They're all are non-metals, so which means they're covalent compounds. That's why I use molecules. And afterward, you'll insert all of this number into your calculator. So grab your calculator, 18.6 times 1 per 2.2 times 1000 divided by 1 times 1 divided by 180 and times 6.022 times 10 raised to 23 divided by 1 mole. Oh, wait a second. And after that, you'll get the result was supposed to be 2.83 times 10 raised to 25 molecules. And we use 2.83 to follow the significant number rules again. And so yeah, that's it. Thank you for watching this video of chemistry lecture. I hope you guys like this, and likewise like this video if you enjoy it. So yeah, thank you for watching. I hope you guys have a nice day. Goodbye.